All right. Sorry, we are back in our trigonometry prep, and today, day 3, we're going to work on unit circle trigonometry. Okay, so if you draw an angle with one side on the x-axis, okay, and you start at the point 1, 0, and go around the circle counterclockwise to place the other side of the angle. So I travel this way, and I make this side of the angle, and this would represent theta, okay? Well, what we do is this point right here would have This point right here would have coordinates x, comma, y. And look at it. If I dropped an altitude from this point down to the x-axis, notice how I've made a right triangle, which is why unit circle trigonometry works, because it's still based on right triangles. And this distance would be my x distance, and this distance would be the length of y. Okay? Notice that x and y will always be between negative and 1, and that's because in the unit circle, the radius is always 1. That's why they call it a unit circle. The radius is 1 unit. So for the angle theta, use the triangle with sides x and y to find the values of the trig ratios. The hypotenuse of this triangle always measures 1 because look at it, it's a radius. Okay, so the nice thing about anything in the unit circle is it's very easy to figure out the other two points because of the Pythagorean theorem. Okay, so once you get that all drawn, okay, and this, by the way, is what we call a reference angle, which we'll talk about more in a minute. But anyway, once you get your angle drawn and all of that stuff, you can count on these formulas working. The sine of theta will always equal the y coordinate. The cosine of theta will always equal the x coordinate. Tangent of theta will always equal the y over the y coordinate divided by the x coordinate. And then just flip them over to get the cousins. Okay? So, they say, for an example, find the sine, cosine, and tangent of angle theta in the unit circle above. Use the coordinates of the point x, comma, 1/3. Well, so they're giving me the y coordinate. They're not giving me the x coordinate. But I can figure it out. If x, we don't know x, so that's x. But y is 1/3, which makes this distance a positive 1/3 because it's going up. You got to watch your signs. Okay? So if this is 1/3 and I know that the hypotenuse is 1, I can figure out the other side, okay, by doing, and let me find some room here, leg squared plus leg squared equals hypotenuse squared. That gives me 1/9 plus x squared equals 1. Subtract 1/9, I get x squared equals 8/9. Type it in, math enter, enter. Square root, and I get x equals the square root of 8 over 9. Simplify that. If I break 8 down, by 2 is 4, by 2 is 2. Square root of 4 is 2, square root of 2. So my x coordinate is a negative because I'm going left. You've got to watch your signs. X is going to be negative. And the square root of 8 is 2 square roots of 2 over 3. So now I know that x equals negative 2 square roots of 2 over 3, and y equals 1/3. So it wants me to find sine, cosine, and tangent. Well, if you're in the unit circle, then I promise you sine theta is y, which in my case is going to be 1/3. Cosine theta is x, which in my case is going to be negative 2 square roots of 2 over 3. And tangent of theta is going to be y divided by x, so it's going to be 1/3 divided by negative 2 square roots of 2 over 3. So to simplify that, we are going to change my colors here. So I'm going to keep the 1/3, I'm going to change to times, and I'm going to flip 3 over negative 2 square roots of 2. The 3's cancel, and I get 1 over negative 2 square roots of 2, which is fine, except for I can't leave a radical in my denominator, so rationalize square root of 2 square root of 2 gives me the square root of 2. This is going to be, and this is going to be negative, this is going to be 2 times the square root of 4, which is 2, which is 4. So my tan theta would be a negative square root of 2 over 4. Easy breezy. Unit circle trig is pretty cool. Okay? Alright. So next we're going to talk about when you're working with angles greater than 90 degrees, which means over here. Oops. Okay, it's necessary to consider whether the trig ratios are positive or negative. The coordinate grid below shows the quadrants in which the ratios are positive. Sorry. Alright, in quadrant 1, all ratios are positive. Sine, cosine, tangent, cosecant, secant, cotangent, everything is positive in quadrant 1. In quadrant 2, only the sine, only the sine and cosecant are positive. All the others are negative. You need to memorize this chart. It really will kind of help you make sure that your answers have the right signs. If you're in quadrant 3, the only functions that are positive are tangent and cotangent. All the rest are negative. And in quadrant 4, the only thing positive is cosine and secant. All the others are negative. Okay? And I meant to erase that. This is on the next slide. Okay? Alright, a reference angle. A reference angle is an angle in quadrant 1 whose trigonometric ratios can be used to determine those of an angle in any other quadrant, angles greater than 90 or pi over 2. The reference angle can be found by calculating the difference between the given angle and 180 degrees or 360 depending on what quadrant you're in. Sometimes a problem may ask for a trigonometric function within a particular range of values. For example, pi over 2 is less than theta is less than pi. Pi over 2 is 90. If you're using a unit circle, this is 0 radians, this is pi over 2 radians, this is pi radians, and this is 3 pi over 2 radians. Okay, we talked about when you measure angles, you can either measure them in radians or in degrees. In degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then of course all the way around is 360 degrees. Alright, but beware, they're going to talk radians a lot. So when they say this, they're telling you your angle has to be between pi over 2 and pi, which means they want you to find it in quadrant 2. Okay, so beware if they put restrictions on you of what quadrant you're looking in. Okay, so they want me to find a reference angle for 135. Well, 135 is somewhere in the second quadrant. They're not being precise here. Your reference angle, again, you can't draw a right triangle with this ray back over here. So what you do is you drop an altitude down to the x-axis, always to the x. You want your 90 degrees always to be with the x. So this here is what we call the reference angle. Well, to figure it out, you think all the way would be 180. I don't want all of that. I want to take this much off. So to figure out that that's 45, we would take 180, subtract 135, which gives me my reference angle of 45 degrees. The reference angle for 300, well, 300 degrees is somewhere in quadrant 4, because remember, this is 90, 180, 270, 360. 300 is somewhere between 270 and 360. So my reference angle, again, I would try and draw an altitude to the x-axis. This is my reference triangle, which makes this my reference angle. Well, now because I'm in quadrant 4, I don't want all the way around. All the way around would be 360. So I want to take off all of this because I just want this left. So take away 300, and that leaves a 60-degree reference angle. Okay? So you try this one, hit pause, come back when you're ready. And hopefully you got 30. So it says, what is the reference angle of 210 degrees? Again, 90, 180, 270, 360, so 210 is somewhere in this quadrant. Which means my reference angle, draw an altitude to the x-axis, this is going to be my reference angle. Oh, excuse me. Well, I don't want all this 210, I just want this much. So I need to subtract off that much, which is 180. So if I take 210 degrees and take away 180, that leaves me 30 degrees for my reference angle. Okay? Try this one. Hit pause. Come back when you're ready. Okay, they kind of just turned you loose on this without giving you any examples whatsoever. Sorry about that. That's the way ACT is. Here's what you do, okay? I'm going to draw my angle. So we want 100. Again, this is 90, 180, 270, 360, 120 is somewhere over in here. Okay? Well, this would be my reference angle. So the first thing I need to do is figure out my reference angle, which would be 180, take away 120, which gives me 60 degrees. Okay, well if that's 60 degrees and that's 90 degrees, then this is 30 degrees. This is 1, because it's the radius, yes? Alright, so I need the legs. Well, in a 30, 60, 90, remember this is the short, this is the long, and I'm going to draw it over here, a generic 30, 60, 90. Sorry, this would be 1. This is the short side. This is the long side. Well, let's not call that 1 yet. Okay, so remember, in the 30, 60, 90, you have your short side. Your long side is x square roots of 3. It's the short side times the square root of 3, and your hypotenuse is double the shortest side. Well, I know my hypotenuse is 1 because it's the radius. So if I say 2x has to equal 1, divide by 2, then this short leg has to be 1/2, and the long leg has to be 1/2 times the square root of 3, which would be the square root of 3 over 2. Okay, what that means is, my friends, the x is, this distance is negative 1/2, because you'd be going this way negative 1/2, yes? Going this way is left. And then my y, my distance up, is the square root of 3 over 2. So my y coordinate is the square root of 3 over 2. We know that sine theta is y, cosine theta is x, tan theta is y over x. They want cosine. Cosine is x. X is negative 1/2. There you go. Bob's your uncle. Alright, so they want me to draw reference angles, or they don't want me to draw them. I have to draw them because I don't see it. 125, there's 90, there's 180, so 125 is over here. So to figure out my reference angle, well, all the way would be 180. Take away 125 would give me a reference angle of 55 degrees right there. Okay? 315 degrees, 90, 180, 270, 360, so 315 is somewhere in here. Well, I want just this much. Well, that would be all the way around would be 360. Take away the 315 will leave me what I want, which is 45 degrees. Okay, what? 425? What am I supposed to do with that? Well, what you do is you go all the way around. One time would be 360. So if I had 425 to go, I've gone as far as 360. That's going to leave 65 degrees that I still have to travel from there. I've only traveled 360 degrees. So I have to go another 65 degrees and drop your altitude. That would be your reference angle, 65 degrees. Alright, 156 degrees, 90, 180, so 156 is somewhere in this quadrant. Well, again, all the way over would be 180. I don't want all the way over, I just want here, so take off the 156 and I get a reference angle of 24 degrees. Okay? Alright, so this says for 5 through 10, find the trigonometric ratios for angle theta in the circle below. Okay, well, if we drop our altitude here, there's my right triangle. The x-coordinate tells me that this leg is a length of 2/3, but left meaning negative. They didn't tell me the y, so I don't know this distance, but I always know my hypotenuse because in the unit circle it's always 1. So to figure out the y coordinate, I'm going to do Pythagorean theorem. Y squared plus a negative 2/3 squared equals 1 squared. Simplifying that, I get y squared plus 4/9 equals 1. Subtract 4/9. I get y squared. Remember, this would be 9 over 9. Take away 4 over 9 would leave 5 over 9. Square root, and I get the y coordinate is the square root of 5 over 3. Positive because it's going up. So my y would be a positive square root of 5 over 3. So now that I know x is negative 2/3 and y is the square root of 5 over 3, and I know that sine is, sine is y, so sine is square root of 5 over 3. I know that cosine is x, which would be negative 2/3. I know that tan is y over x, so I would have the square root of 5 over 3 divided by negative 2/3. Keep, change, flip, darn it. I have the square root of 5 over 3 times negative 3 over 2. The 3's cancel, and I'm left with a negative square root of 5 over 2. And to get the cousins, just go back and flip them over. Cosecant's reciprocal to sine, so cosecant theta would be sine flipped over, which is 3 over the square root of 5, but I have to rationalize that. So square root of 5, I get, for cosecant, I get 3 square roots of 5 over 5. For secant, flip cosine, so that's going to be negative 3 over 2. And for cotangent, flip tangent, which, what was my tangent? This one? So if I flip that, I'm going to do it over here because I don't have to rationalize. I'm going to get a negative 2 over the square root of 5. Rationalize, square root of 5, square root of 5, I get negative 2 square roots of 5 over 5. Okay? Alrighty. So, you try this one, hit pause, come back when you're ready. And hopefully you got 65. They want the reference angle for 245 degrees. 90, 180, 270, 360, 245 is somewhere here. So I need to find this reference angle, which would be, this is 245, right? So it would be, I don't want all of this, so I want to take away that much, so I'm going to start with 245 and take away 180, which gives me 65 degrees right here. Okay? Try this one, hit pause, come back when you're ready. And hopefully you got G. It says, what is the reference angle of a 396 degree angle? Well, all the way around would be 360. I need to go more than that. How much more? I don't know. You've already gone 360. What's left would be 36 degrees more. So my reference angle would be 36 degrees. Okay, try this one. Hit pause. Come back when you're ready. And come on. There you go. There you go. Hopefully you got E. Alright, so 300 degrees. I'm going to draw it. 90, 180, 270, 360. So 300 is somewhere over here, which means my reference angle is 60 degrees again. So if I come over here, and I'm going to redraw my triangle the right way, would be nice. Okay, so if this is 60, this is 30, that's 90. This is short, this is long, this is the hypotenuse, which we know is 1. Short, long is short square roots of 3, hypotenuse is double the short. So again, in a unit circle, that hypotenuse is a radius, which is 1. So 2x, this hypotenuse has to equal 1, which means x has to equal 1/2. So the x-coordinate of this is 1/2, which means I'm going, and it's positive because I'm going to the right. The y-coordinate, if x is 1/2, the long would be 1/2 times the square root of 3, which makes this the square root of 3 over 2. Negative because it's down. So my y-coordinate is a negative square root of 3 over 2. And sine is y. Sine theta is y. So sine 300 is a negative square root of 3 over 2. Done. Okay, cosine of 225. Hit pause, come back when you're ready. And hopefully you got J. Alright, 225, we got 90, 180, 270, so 225 is somewhere over here. I need a reference angle. I don't want to go 225, I just want to go from 180 to here, so take off the 180 on top, and that will leave me 45 degrees. Oh, cool. That means I have a 45, 45, 90 right triangle. Let's draw that to the side. 45, 45, 90. So my legs have to be equal, and my hypotenuse is, if these are both x, then this is x square roots of 2, which I know that hypotenuse is 1. So to get x, divide by the square root of 2, and I get x equals, rationalize, the square root of 2 over 2. Okay, but, so the x-coordinate is square root of 2 over 2, but it's negative because I have to go left. And oh gee, legs are equal in a 45, 45, 90, so my y-coordinate is also a negative square root of 2 over 2. Alright, and they want cosine. Cosine is x, so cosine of 225 is going to be the x-coordinate, which is a negative square root of 2 over 2. Okay. Alright, last one. Try this one. Hit pause. Come back when you're ready. Alright, so it's got sine of theta is negative 3/5, and they want their theta to be between pi and 3 pi over 2. So, we would have, again, in radians, we go 0, pi over 2, pi, 3 pi over 2. If they want my theta to be between pi and 3 pi over 2, then my reference angle is somewhere in this quadrant. So, now that I know what quadrant I'm in, drop an altitude, and it says that sine, which is opposite over hypotenuse, opposite of my theta would be negative 3 because it's going down, and the hypotenuse is 5. So we're not in the unit circle because that's not 1. Anyway, they want tangent, which is opposite over adjacent. Now, you can do the math if you want, and oh, by the way, this hypotenuse is never negative. You can do the math if you want to. You could do leg squared, because I'm going to have to figure out they want this side, which is going to be the x distance. Alright, so if I call that x, they want that. Well, you could do x squared plus leg squared equals hypotenuse squared, which would give me x squared plus 9 equals 25, which gives me x squared equals minus 9 is 16, which gives me x equals 4. Or you could have memorized anytime you have a right triangle with there's the most famous Pythagorean triple is the 3, 4, 5. So that would tell me that x is 4, but it's negative because we're going left. Okay? So now that I have all my sides, tan theta is opposite over adjacent. Well, opposite me is -3, and adjacent to me is -4. And a negative divided by a negative gives me a positive 3/4. Alright, good job, and I will see you next time for day 4.